projectile motion in an inclined plane. But before that, what is inclined plane that I am going to tell you. This is an inclined plane. You know that it is a simple machine, and here alpha is the angle of inclination, and if a particle is thrown with a velocity u by making an angle theta with the horizontal, then the trajectory of it is something like this. If I consider the point of throwing as O, then OPQ basically shows the inclined plane, and here I consider the XY axis like this. When we are discussing the projectile motions on a horizontal, at that time we consider XY motion like this. But here I have considered it like this way. Okay, just making an angle alpha so that x-axis is attached with the OQ plane of the incline and y-axis is perpendicular to that of the incline. So along the x-axis, the component of the initial velocity ux equal to u cos theta minus alpha, because the angle is here theta minus alpha. Okay, the angle made by u with this OQ is theta minus alpha. Similarly, uy, the y component of initial velocity is u sin theta minus alpha. Projectile motion is considered under the gravity. The acceleration due to gravity is acting this way and each and every point on the inclined plane. So it has two components. One is along these directions and another is along these directions. If it is alpha, then the perpendicular to OP and OQ, just see, perpendicular to OQ is this line and perpendicular to OP is this line. So this angle should be alpha. If it is alpha, then should be G cos alpha and this should be G sin alpha. So G cos alpha in the directions of the negative y-axis. So the AY is equal to minus of G cos alpha and AX is equal to minus of G sin alpha. Okay. So along the x-axis it have an initial velocity, it have an acceleration. Here also it have an initial velocity and it have an acceleration. So along the x-axis and along the y-axis, in the both cases the particle is moving under constant acceleration and starting with the initial velocities. So if I consider the motion along y-axis, and you know that the motion along y-axis gives us two informations. The informations about the maximum height and the informations about the total time of flight. Okay, but here we calculate this thing like this way. Let 0 is the point of throwing, capital A is the point of reaching the maximum height, and capital B is the point where it strikes the projectile. So if it is, then I can write down 0 square equal to plus of uy square plus of 2 minus of G into capital H, if capital H is the maximum height. Here we have used the equation v square equal to u square plus 2as. When it reaches the point maximum height, at that time the final velocity is 0. When it is thrown from here, the y component of initial velocity is uy. The g, it is the acceleration, it is not g actually, it is actually the g cos alpha, the y component of the acceleration. So if I do this from here, capital H equal to uy square divided by 2g cos alpha. So uy means u square sin square theta minus alpha divided by 2g cos alpha. So if I want to see it tactically, what it is actually, capital H equal to uy squared divided by 2 of ay. Actually this value gives us the maximum height. Here uy is u sin theta minus alpha and ay is g cos alpha. So the expression of the maximum height is u square sin square theta minus alpha divided by 2g cos alpha. So if I want to calculate total time of flight, the time taken by particle reaching from O to A, then A to B, then we have to write down the equation along the y-axis. And the equation along the y-axis, y equal to uy, sin is moving along the positive y-axis, constant is plus y, and the initial velocity is y component is uy plus of uy into small t plus of 1 by 2, and along the y-axis the acceleration is ay, that is minus of g cos alpha, so it is minus of g cos alpha and t square. This is the equation of motion along the y-axis. When the particle reaches from the O to A and then to B, then the total displacement along the y-axis at the end of it, at the end of the motion, is 0. So from here we also say the time, at that time t, we can consider total time of flight, and the value of ey if I put, then it will be u sin theta minus alpha into capital T, u sin theta minus alpha into capital T, 1 by 2 into minus of g cos alpha into capital T square. So from these equations we can see that it is capital T u sin theta minus alpha minus of 1 by 2 into g cos alpha, here is again capital T, and it is equal to 0. So this equation gives us the particle at y equal to 0, at t equal to 0 at the point of starting, and u sin theta minus alpha minus of 1 by 2 into g cos alpha into capital T equal to 0. So from here capital T equal to u sin theta minus alpha g cos alpha into 2. Okay, so it is basically nothing but 2 of uy divided by ay. So t equal to 0 when the particle is here, and t equal to 2u sin theta minus alpha divided by g cos alpha when the particle is at the point B. So this is the expressions of the total time of flight, and this is the expressions of the maximum range. Okay, so what we have derived, we are writing here capital H equal to u square sin square theta minus alpha divided by 2g cos alpha, and the total time of flight that we have derived, it is 2 of u sin theta minus alpha divided by g into cos alpha.